the chat that yes, you can hear me and you can see me. Great. So I must gets a message from my Kapoor. Right. So this first step to artificial intelligence is AI master class to get you started. And this is a 2-day session. So today and tomorrow, and each session will be of 2 hours. And we'll try to keep the Q&A section at the end of the session. I will take some Q&A in between also. And if you have any specific questions, please put it up in the chat. I will try to pick it up whenever I can. And also that we'll try to keep this session a little interactive, and make it fun for everyone so that we have a good time on Saturday and Sunday. Understandably, that tomorrow is also a festival, so let's keep that energy going, right? So I think it's a good time now. We are at 12:35. Good time to start. Okay, just give me 1 second, please. Okay, great. Good to start. Good morning, everyone, rather than good afternoon. Uh, and Today we are all here to understand what is the first step to artificial intelligence. Artificial intelligence today is kind of defining a lot of future, you know, uh, a lot of future functions and a lot of future conversations. In fact, it is fueling a lot of future conversation. And in a recent PwC report where they surveyed more than 100 global CEOs, they figured out that 85% of those CEOs believe that artificial intelligence will be very, very critical for their business, and secondly, to be a leader in their business. So actually, it becomes critical for every one of us to kind of start understanding that how can become a part of this revolution and not be left behind. All right. So let me share my screen and we will kick off the presentation. Just give me 1 second. Let me pull in the presentation first. Um, okay. So before we start, I just wanted to kind of make it simple because we are now in a digital world and digital event space, so that in case I lose my internet, or in case anything stops, I should be back within 2 minutes. And we have other people from we have Piyush and Talvinder also from Pragmatic. So in case, so stay there, right? Don't leave. If anything stops, it will come back. We'll come back, and you can come back also, because at times in some webinars I've seen that people log off, but it will not happen here, right? We have taken care of that. All right. So I hope now you can see my screen. All right, and I'll just take the presentation. Great. All right. I hope you guys can see my presentation. Piyush, can you confirm that you can see my presentation and you
Yes, we
can hear
can.
me clearly?
Yes.
All right. Great. Great. So welcome to the first step to AI Masterclass Day 1. And before we kickstart our masterclass today, I will just try to take you through an interesting story, that how me Pallav, right, and then I'll also that will give some introduction of mine also, uh, of me in terms of as an expert. So my story of learning AI the hard way, right? So how did I start learning AI? In 2015, I was heading product at policybazaar.com. And then that is when I decided to quit Policy Bazaar and start my own venture by the name of iStyle which was a conversational platform between fashion experts and users based on their profile. And I started back in August 2015. Fortunately, we raised funding, venture capital funding, and we also raised money from Ranvijay Singh. So Ranvijay Singh is, to people who don't know, is a big celebrity in India. And when Ranvijay Singh invested in our company and became our brand ambassador, you know, we suddenly see our engagement matrix go beyond the roof, right? So we were that point of time, suddenly within a couple of days, we were seeing our engagement going to 20,000 on a weekly basis, right? We were now engaging with 20,000 new users. There were 2 million messages which were being exchanged. There were around 150,000 product recommendations. And all of this was being driven by over 100 plus stylists. So what happened was, this was something great, right? As an entrepreneur, as a founder, and as a product guy, I was extremely happy to see these kind of numbers being achieved, right? And everyone was pretty happy. And so what we did was that our team went on to improve our recommendation engine. We improved our search engine. We optimized chat to the best level, right? Of course, working late. If you're in startups, you have to work. We hired tech guys. We kept optimizing performance. And we did everything under the sun to improve our technology, to keep to uh, to keep this spike going up, up and up, right? But all was going good. Everything was really looking good for us, right? And I was really happy. I was sleeping less, but I was still very happy, right? And better for any entrepreneur to see these kind of numbers. But there was one thing that was concerning me a lot, because as we kept on increasing the number of customers on our platform, the cost of service kept on increasing, right? So cost of per customer, right? So per customer, so if we had 1,000 customers, the next 1,001 customer was getting expensive. 1,002 customer was getting more expensive to handle. So the cost of servicing each customer was increasing as we were going by. And this was giving me sleepless nights, because this was not a viable business model, or not a feasible business model. Because if your cost of servicing keeps on increasing, then we are never going to achieve profitability. And this was a critical problem in our business model. So what we did was, we kept optimizing, but you know somewhere, during the back in 2016, I was thinking that we need to automate, and we need to reduce our cost of service, right? And we need to do something different. And that is when, in 2015, 2016, artificial intelligence was coming in, right? In terms of Google was talking about it. Google had released its model. That time was when TensorFlow had started coming in. People had started talking about deep learning and everything, and there were some platforms and some kind of. But that time, I always remember, there were many. Suddenly, there was a spurt of lot of courses, right, which were available online. And There were a lot of online courses from Coursera, from many other platforms, online learning platforms that were available. And in fact, in my investor meetings, when I went out, the investor told me that you should kind of look at artificial intelligence to reduce your cost of servicing, and do something to automate your business process and everything. And so I started researching about artificial intelligence in 2016, just to do one simple thing to reduce the cost of servicing. All right. I took up some courses. My technical team that time had little understanding of what is artificial intelligence and how can we apply it. And I'm talking about early 2016, when AI was still very new. And I took up these courses from Coursera, and other other learning platforms. And every one of all these, they were great courses. Yeah, they were very good courses. But each of these courses, the problem of what I was facing was taking me too technically deep into coding, right? And they were talking about, there are so many algorithms in artificial intelligence, and if I keep reading about them, right, I would have spent a year almost, or year and a half, and still be nowhere. I did not have time, right? The time was running out. These courses were not helping me to kind of lead my technical team to solve an AI problem, right? And basically, I had to kind of keep trying, and for over 6 months, right? What we did was we did a lot of these small projects. We kept on doing projects. We tried. I helped them. I understood that I, along with my technical team, uh, I guided them, because I had by then read a lot about AI and convinced these guys that there are certain things which we can do with AI which will help us reduce our cost of servicing. And that is only when we started experimenting, and we did a lot of things to come out with eventually an instant styling advice platform, where someone could have created a profile. We did a style analysis within 20 seconds, and the styles delivered was within 30 seconds, right? We did, but this took us good 6 months of a lot of practical application, right? Wherein I read about that how instant styling advice works, how artificial intelligence can help me, and how can I lead my technical team to do that, right? Because the tech team did not have much of an idea around that time, right? And it was not I had to move out of Coursera. I had to move out of online learning platform, read a lot of blogs, read develop an understanding that should I be focusing where, how should I be learning artificial intelligence. And we went on to develop an instant styling advice, for which our startup was acknowledged as amongst the 7 startups that would transform the business of retail. And we were acknowledged, and we were loved by a lot of retailing platforms. So the point I'm trying to drive is that I did not come from IIT. Neither we had an access to MITs, or we did not have an access to AI labs. Neither a mentor like Andrew NG helping us out. But there was only thing, and we were, none of us was this a nerd, right? A true hands-on nerd. But that this was one thing, right, that kind of helped us scrape through and develop an understanding of artificial intelligence, and I was able to guide my team and develop great applications. Was that we learned by applying. We learned by applying, and that is called applied AI. And these were hard 6 months that we all fought. But we did not. We are my one very single objective was that learn by applying and learn by applying, and that is the genesis of my current program, which we have designed at Pragmatic Leaders, where it is a project oriented program, right? And we are developing an AI mindset through that, which the mindset which I developed over a period of last 5 years is what is a part of that program, right? So and it's a very very, because that's what we have learned. And I've always, after trying to learn through those online courses, what I learned was that now we are adults, right? We need to move out of the classroom, the traditional classroom approach. Then from there we went on to be we went on to represent India at London Tech Week, where we were awarded for our AI retail innovation, where we developed a smart mirror IO screen. We were recognized at London Tech Week. We were acknowledged by Startup India as an innovation, and also acknowledged by Tech in Asia, which is a leading tech column in tech website in Asia, right? So we were given a lot of these From there on, I have developed and worked on a lot of solutions, CCTV camera solutions, also on fashion technology solutions, and have been in this space of AI projects, developing these AI projects for a while, right? And what has helped me from where I was to where I am today is this AI mindset. It is this ability to think that how can I solve a problem effectively by using AI is what has now made me in a position that given a problem, I know how to apply artificial intelligence and get coders or developers to be a part of that team and help me execute that project. Right, and that is what is the most critical asset today I have is my AI mindset. Right. So when we talk about a project, right, it is about that how do I develop an AI project, right? And everyone suddenly would start thinking, okay, let me get a data scientist, let me get a coder, Python coder or someone. And in an AI project, and I've roughly done corporate level projects, around 6 or 7 of them, and successfully deployed them, right? The contribution I can put in very easily, and if you want to check with anyone, for that matter, the contribution of a coder is less than 25%, right? Because when we're talking about a project can never be delivered by one person or a one software developer, right? The project, the team has to come together, right? Starting from, you know in a project, there are three important functions. One is the business requirement, second your business requirement, second is your product understanding, the product, product engineering, and then finally comes your software engineering, right? Similarly, to crack an AI project, you need all the three. All right, you need all the three to be in a similar mindset. Otherwise your project cannot be successful, I can guarantee you that. And for that very reason, right, when I walk into an AI project, I always try to do a couple of workshops in corporates where I make them understand that what's an AI mindset, what should be the expectations, what kind of things will happen, and then I also sit with the development team to make them understand, right? Otherwise the project is 110% going to go for a toss. Okay, so my success rate has been successful for that reason that I understand this concept, right? And everyone plays a critical role. This person and this person, all the three play a very very critical role when an AI project needs to be cracked. Okay, so I've been through this whole story, there are a couple of points I wanted to drive. Was that you know AI is not only about coding, right? It is a lot more than coding, right? It is, and if I have to tell you what more than coding is important, is the AI mindset. Okay, so that will be critical, and I'll prove. I wanted to prove it to you with this small interaction, right? So I do this activity with a lot of people where I say, okay, and we'll do this interaction, and you can put things in the chat, right? So on a trip to Ladakh, right? If I was traveling with my wife, and you are my travel agent, given two options, a Ferrari or a Land Rover, which car would you suggest me? Right? Which car would you suggest me? And you can put that in the chat, right? And let's take 10 seconds. And Piyush, can you help me read out what people have written in the chat?
Yes.
Right. So what's the majority?
Land Rover.
All right. Yeah. And it's right. Right. So yeah. On a date in Paris, right? On a date in Paris, which car would you suggest me? Right? Would that be a Ferrari or would that be a Land Rover? Can you type in? Right. So we have got some answers, right? Going in. What's the answer? Majorly.
Majority is Ferrari.
Right. So yes, majority would say that on a date, on a trip to Ladakh, we should go for a Land Rover. On a date in Paris, we should go for a Ferrari, right? It's simple, right? It is pretty simple because Land Rover has a 4x4 wheel drive with high ground clearance and the off-roading capability would be the best suited for mountain driving. Whereas a Ferrari, which has a V8 engine, it gives you a lot of speed. It is about design, it about luxury, and that would always impress my partner in a Ferrari, right? Uh, the only point I wanted to make here, do you did you want to know that what is the piston technology of the engine of these two cars, right? I don't think so, right? Just give me 1 second. Yeah. So you don't need to talk about the piston technologies of these two cars, right? That what goes inside an engine, this engine, and within this engine, how does a piston work? And within a piston, how does a PRCIVEW work, right? What you needed to know was pretty simple. Yeah, sorry. What you needed to know was pretty simple, right? You needed to know what's the location, what is the purpose of the trip, and the car that would best suit the trip, right? So you don't need to be an auto engineer or, for that matter, be a mechanical engineer to solve this problem, right? And this is a business problem, right? And as a business manager, as a project, product, or designer, anyone for that matter, these are the problems you solve in a real life scenario, right? Where a question is asked and then you figure out, okay, what is the best option based on the strength of each option you tell. In a very similar fashion, artificial intelligence has got more than, I can safely say, more than 150 algorithms, innumerable number of models, and more models are coming every day. Right. So currently there's a model called GPT-3 which has come out. Before that there was YOLO which had come out. Before that there was another model which had come out. And ask, and I can guarantee you every data scientist doesn't know everything. Every AI engineer doesn't know every algorithm. Right. What you under AI mindset need to know is that which model has what strengths and in which situation would it lead to a better solution, right? And that is what is more critical than getting in depth of each model. If you go on to understand those 150 models, you will probably spend, I don't know how much time, maybe 2 years, 3 years, eventually losing out the and the way things are moving, right? The way the progress is happening, you will be again 3 years back, right? And that's is what is critical for you to understand, that how do you kind of keep working on this. Okay, so it's very critical. Remember this whenever you're confused. Remember this. Remember that on a trip to Ladakh, what I did I select. On a trip to Paris, what would I select and why? Right. That will give you a lot of clarity when you get confused whether should I learn a lot of in depth. Right. Uh, and today the good part is that there's a lot of AI enthusiasm that's there, right? So PwC report says, okay, 85% of the 85% of the 85% of CEOs are saying that AI is important. Even 79% of people from management, in the management or in on an executive level, are saying that AI is going to introduce major or significant benefits, increased efficiency and lower cost, right? So it is now that it's happening, right? It's not that it's a futuristic thing, but it's happening now. But the adoption rate is low, and the movement happening is less. And this is the one only reason. This fear, right? The fear of complexity, the fear of unknown, and the fear of coding, right? Are the three most uh, top rated fears when it comes to learning artificial intelligence. And you know this is what makes me this has kind of made me risen up and said, okay, let me solve this problem for people who, when I said 25% and when 25% is the only contribution of the coder, then what happens to the first 75%? Where do this 75% learn from and get away this fear, right? And that is where, I spent a good amount of time along with Alvinder and also with the industry, with the academia, where we thought that the most critical part is to learn by doing, not learn by learning, right? Not the typical classroom model, right? And that is the completely a project based approach that we have taken. Okay. And today this enthusiasm is because even McKinsey has come out saying that AI is going to create a value of, by 2030 it will add $13 trillion to the global economy, right? And if it is $13 trillion is almost as much as the economy of the whole of US in 1 year, right? So the impact is huge, right? And the enthusiasm is huge. It's just that the complexity or fear of complexity and coding is kind of taking a little helping, not helping us, right? And that kind of a thought process that we need to learn a lot, and you of course need to learn, but you need to learn it the right way, and that's very critical. All right. So to get you started, the best part is always look at how artificial intelligence is impacting us today. Right? How is it around us? Because that will be okay. Because that's critical, right? So first we need to understand that how artificial intelligence is impacting our lives, right? uh, and if you understand this will be a good first step to understanding artificial intelligence, right? So a simple example, Google, right? And we all know that Google is the is a synonym for search in this world. And why? Because it delivers highly personalized search within zero point 0.3 seconds. Okay. And why, you need to understand why no one has been able to beat Google in its game and has been a monopoly for the last good I don't know, maybe 20 years, maybe 15 years, right? No one has been able to come near to Google, right? And what is the reason? Because it provides the personalization is to such a high degree that you always amongst you always get your search right within the first two three first two three results Google show, right? And what is the reason? Of course, everyone would say, all right, yeah, it is artificial intelligence, but there is one more thing, which I don't know whether you know or not. But Google, before delivering that personalized result to you, calculates 64 attributes of yours. There are within zero point 0.3 seconds. So mind it. So within zero point 0.3 seconds, Google calculates 64 attributes of yours to give you a personalized search. And when I say 64 attributes, when I came to know about it, I thought, okay, how many attributes do I know about myself? Right? How many attributes? Okay, so I know my name, Alav. I know my location. I know my gender. I know my age, my weight, my skin color, uh, my education qualification. What else do I know about myself? Um, okay. Um, my designation, um, the company I work for. I think 10 I've told you, right? And let's make this very interactive because it will be a fun thing for you also to understand. So out of the after these 10, can you put it in your chat where we need to achieve till 64? So I have spoken about age, weight, my height, all those stuff which I've talked about. So I've gone on to tell the company I work for, the location, the house where I stay, maybe my parents' name. Can you add more to those attributes? Right. So you can put it in the chat. I've already, you can put it in the chat where I just want to ask you guys that what more attributes can you kind of see? All right. So it says interest, hobbies. I know about relationship status, previous search. So we have search history is the same thing. Okay. Experience. Okay. One, two, three. I have four, five attributes. Six, um, seven, eight, nine, 10, 10 attributes I've got. All right. I've got majorly 10, 11. Niti says child or not. That's right. Religious beliefs. Okay. So 11, 12. Device I use. Bank details. Okay. Shakti Das, social circle, Arjun, policies. All right. So we have reached around maybe 16, 17 by now. Political side. Great. Utsav. That's nice. Vivek, travel, okay. Whether how much do I travel? Okay, frequency of travel, movement patterns. So, Aniti, you would may not know movement patterns based on maps. So, I'm asking, what do you know about yourself, right? Not what Google may know. Let's first try to understand. Okay, the vehicles I own, I know about themselves. So we have reached 20 now. Okay, do we have more? I will just reiterate the ones which have been written. Uh, okay, experience, interest, hobbies, relationship status, previous search, location, um, what often is searched on Google, medical conditions. Okay, we have still some online shopping patterns, wants, needs. Okay, great, Uday, makes sense. Wants, needs. We have still reached approximately around um type of house, makes sense. Niti, right? Wants, needs, reading habits, daily devices. That has been Shakti. That has been covered, but yeah, nice. So we have reached 25 attributes by now. Okay, taste in films and TV shows, right? So 26, and now it will get even more harder to think, right? 26, we can probably, if we keep thinking, we can economic status, right? Makes sense, Rutuja. Um, so if even now colors, yeah. So right. So I'll just now close this, and we now it's getting difficult, right? So because now we are repeating some of them now, right? Rather nice. So can you now see that we have already covered 35, 40, right? Now Google uses 64 of them. Yeah, and that is why 64 maybe adding to 70, and that is what Google, it makes sense. Now we can stop on the chat. I think we have covered, and amazing, great. I'm so happy that we know that we have so many attributes. But can you imagine that within zero point 0.3 seconds, right, Google calculates all those and gives you the right search, and that is why Google is Google today. Now, talking about Netflix, right, the father of binge watching, right? How many times has it happened where you say, just at like, just I think day before yesterday, back at I think 12:30 in the night, I got up, I was not able to sleep. I said, okay, let me watch one episode, and then I went on till 5 o'clock, right? How did that happen, and why it is that does that happen for a person like me, who is, I think I'm mature, I'm old enough to understand that I need to sleep early, but Netflix gets me every time, right? And that is the beauty that Netflix has been able to build such strong analysis that what kind of, what kind of movies would I like, and within in the movies or within the series, what should be the sequencing of each, of each episode, such that the person doesn't leave the table, right? And this is of course a part of creativity, but they have used data and merged it with creativity to, make binge watching a culture and make Netflix a noun, right? So we say, okay, we don't say we will watch a movie, we say, okay, let's Netflix together, right? And it did not happen because they were just creative, right? Because there were many creative movies before, also there were many creative series there. But why did it happen? that every time you leave one episode you want to watch the next episode. And the beauty is that they have used the beauty of data and creativity to bring you an understanding that what makes within you makes you believe that you want to watch another movie. And your heart overtakes your brain. Okay. So, and they have engineered it. And how many times has it happened that you've gone to Amazon, and you've purchased more than what you want, right? Or purchased something else. And today, Amazon, the leading e-retailer in the world, for that reason, because 35% of their recommendations they earn through the recommendations, because the recommendations are extremely personalized. As and and they exactly know the data they have crunched. They exactly know that if on a Sunday evening someone is opening Amazon with those attributes, they exactly know that what is the highest chance of this person looking at, right? And that is why they drive great engagement on their apps, on their websites and everything, right? So these are the things, right? And we have been I think a lot of this we have been you know a lot of these applications, yeah, we have been looking at, and we know somewhere about them, that how are they using AI. But we need to get into the depth of it and kind of understand that how they're doing it, how a recommendation engine is helping them to develop and become the most valuable companies in the world, right? Now, let's look at India, right, and see that how in India, right, we are using artificial intelligence. Is it all about technology? Is it all about technology companies that are using artificial intelligence to get more people and to get more revenue? uh, it is now, the beauty is now AI is percolating across each industry, whether it is tech, whether it is not tech, and within each industry, across each business function. That is your human resource, marketing, project management, product management. It is basically now getting into every business function across every industry. Okay. All right. So let's take an Indian example for that matter. IRCTC, right? I'm sure a lot of people know what is IRCTC, and to people who do not know, IRCTC is the company which kind of is the booking. It is the company which is taking care of Indian Railways in terms of booking, food, and a lot of other activities, right? But what is it is famous for is its you know was it is infamous for two things. One is website not working. A lot of times you go onto the website is not working, but it is also very infamous for the food not being great, right? And there are multiple reasons for the food not being great. Either there have been cases where there have been cockroach inside the food. Unfortunately, there have been cases where there have been insects inside the food, and the food is not tasty. The food is stale, and there are many. If you just go on to the Google and search for issues with IRCTC food, you will find some disturbing images. But that has been what it has been for, right? Uh, and and if you see that, you know, uh, IRCTC has used AI, that is your computer vision, to build kitchen hygiene audit. Surprised? Right? A company like IRCTC is also investing in artificial intelligence to do kitchen hygiene audit. And here is an example what they're doing. Right? So it's basically they're talking about they're doing headgear detection within. So they have, through those CCTV cameras inside the kitchen, now they are being able to do headgear detection, right? So they can identify whether someone is wearing a cap, or the chef is also wearing a cap, right? Because if the chef is not wearing the cap, there is a very high chance uh, that some elements from his hair or her hair would fall into the food, right? Or the hair would fall into the food. So one is headgear detection. Second is uniform, to also see that there are no outsiders that are entering, and there is no. So that's what they're doing. They're also checking for floor mopping detection, that how many times the floor mopping happened in a day. And they're the most important thing is they're also checking for any animals or rodents or a mouse entering the facility, and they want to know whether it has or whether not. So this overall, you know, has really helped IRCTC improve their food standards, and which also have helped them improve their customer satisfaction score. Right, that is a CSAT score. Right, and you will be amazed that today IRCTC is being awarded by the government, and you know, for doing this, for using artificial intelligence for hygiene or food in trains. Yeah. So next time, if you have an IRCTC kitchen nearby you, try to walk in and see that how this works, right? Or maybe if you can get someone to speak to, and it's a very interesting use case, right? So it uses video analytics to identify rodents, whether chefs are wearing caps. Um, Talk about cleanliness. It looks at attendance. It looks at employee behavior. Yeah. So this is a very beautiful, and it's a made in. I don't know whether, but it seems maybe it's a made for India or a made in India application, and it has been developed by an Indian startup. uh, Fortunately, uh, I know the founder, who's a very good friend of mine. And when we were developing, so I was just looking at them when they were developing this, I was amazed. Right, that how they were able to crack this. And mind you, I'm telling you one thing, my friend who runs this startup, right, doesn't have a coding understanding, right, but he has been able to develop this more because he he also developed this kind of thought process, that how can I help IRCTC using CCTV cameras do hygiene audit. And the concept of understanding this does not come from a developer, but it comes from a whole thought process, from a business thought process. And then dividing and understanding that we can identify rodents, chef wearing, cleanliness, attendance, and employee behavior. How will we do it? How are the cameras going to be placed? And eventually, after figuring out the whole thing, is when it comes to the coding part, right? So that first 75% is pretty critical, very critical, and not those last 25%. Okay, so it's pretty critical on that front. And what it led to, it was this beauty, which kind of it led to where they even just at the standard of product, the standard of food kind of was so good now. There's some issue with the chat. Okay, all right. So I'm not reading through the chat. I just thought there were many messages, but I'll take it up later. Uh, and they started delivering great food, great standardization using computer vision. Yeah, this is a very good application. Now, around 5 or 10 years back, even in metros and even non-metros, you go to some banks and you would see a lot of big lines for personal loan, for loan applications, right? People standing, people submitting their documents. There are innumerable of number of documents that need to be submitted for getting a personal loan. Or back in 5 years, I'm not saying today, but back in 3 4 5 years back, you have to do a lot of activity to get a personal loan, and spend over maybe 15 to 20 days to get a personal loan, or maybe home loan. It may take you 2.5 to 3 months. Um Today, India Bulls has an app called Dhani, um, which says phone say loan anytime, anywhere, and it does that within 3 minutes. So I probably just said it 5 minutes, but it does that within 3 minutes. If everything is perfect, within 3 minutes, it is disbursing loans between the range of 1 to 3 lakhs. All right, and it is easy, man. Now you just need to open the app, put your documents in, put your CIBIL score. The CIBIL score comes out automatically. Payment history is generated, and I'll tell you what. Basically, they are verifying documents using OCR. All right, so you upload your documents. The OCR figures out, whether where this name, where is this, and whether this document is the right document or not. They are using a lot of online data to identify your profile. So as soon as you put in your profile, they it will crunch a lot of numbers, and figure out your profile. It identifies your CIBIL score, payment history, and puts that into a big engine, which that engine is either a regression model which eventually scores you and tells you, which gives a score that for this person either he should be given loan or not given loan. That is one. And if he has to be given loan, then how much of loan can we approve, right? All on the basis of getting data from all of these sources and building a model which is as good or better than a human judgment. Okay, so we are from here, we have moved here. Yeah. And in a I have got a chance in the last 2 years. I've got a chance to do workshops in corporates, work with corporates, and do a lot of these academic workshops also. And I've always told them about this one point, right? That AI is not about those futuristic robotic and robotic arms. It is about that, but still we are away from them, right? And that they may have some applications in the US or in the world, but it's about today, and it's about identifying these problems, right? It's about identifying these problems and having the capability to think that this problem can be solved, and then bringing in the capability of solving that problem is so critical. In all my corporate seminars and corporate communications, what I do is to help first develop the AI mindset, get them to understand, get take away the fear. So first is to develop the AI mindset and take away the fear of coding and complexity and everything away from them, right? And then help them apply that artificial intelligence, right? And that is what is the genesis of uh, a PG certification, PG certificate program in AI that we have developed, that I along with Alvinder have developed, uh, where our focus is more towards project based learning, right? Our focus is to go away from the classroom learning, right? The classroom learning which always we have not really appreciated, right? All like we do our schooling, then we do our college, we do our MBAs and everything, and we have always not appreciated classroom learning much, right? And that is my learning which I've imparted and meticulously designed this program, where we want to impart you in a very different pedagogy, a pedagogy which says practical project based learning. All right, so just telling you the modalities of this program. The For this program, the admission starts tomorrow. We are admitting, we're taking in a small batch right now of 5 to 6 students, and the program goes live by 31st. So this first cohort, we are inviting around 5 6 students only, on the basis of your application. And So we are admitting around 5 6 students, and you can reach out to us on admissions@pragmaticleaders.io, or schedule a call with me, and even Piyush can share a link that where you can get an access or an understanding, right? So I just wanted to tell a little more about our methodology and our approach, right? And where we have developed this from. Yeah. Okay. A lot has been said, and I think I've put in a lot of, just wanted to have, we have covered a lot of things more from a practical point of view. Uh, Now moving to the basics. Yeah. So I'll just grab some water and let's see. Okay, great. All right. uh, I was just thinking to break the ice before, but let's start. I think I was just thinking that if I can crack a joke, but I don't have one right now around AI. Okay. So let's talk about the basics of AI, right? So there is a lot of confusion because of many reasons and many definitions that are floating around artificial intelligence. There is no one definition that is right and that is wrong, right? But I love this definition of artificial intelligence, where it refers to the simulation of human intelligence in machines that are programmed to think like humans and mimic their action, right? We humans, right, have two very critical aspect. One is the aspect of learning and the ability to solve a problem, and that is what we are making, what we are trying to make our machines learn, right? The and providing machines the capability to learn and solve a problem, right? And that is called artificial intelligence. All right. Okay, great. So just putting up a simple visual here, where like machines, we humans also learn from multiple types of data, multiple types of experiences, and we constantly keep learning over a period of time until and unless we become an expert in that. Similarly, what we do is we make machines learn, right, and make them learn and perform activities. All right. So I'll just quickly take you through some of these capabilities that we are trying to build in machines. So what the first capability is computer vision, where giving computers the ability to see like humans see and interpret like human is called computer vision. Second is natural language processing. So giving the machines the capability to read and understand from the text is natural language processing. Okay. um, Then we talk about video analytics and recognition. So again, giving machines the capability to hear and recognize what's happening is called video analytics and recognition. Then giving machines the capability to move around like humans is called robotics. All right. And last, the most important ability to learn and become intelligent is what we are giving machines the intelligence. And that is what we are building neural based systems inside these machines to build the intelligence for them to take the data and also solve the problem intelligently, right? What we need to see is that how we humans learn, right? We humans learn throughout our lives, right? And we keep learning from multiple sources of data, right? It can be audio, video, books, and it can go on and on. Yeah. Similarly, we make machines learn, right? And that is the concept of machine learning, that we are making these machines learn from a variety of data. All right. And just to bring in that perspective, to train the model is to make the model learn the similar the way child learn. All right. So this is how is what is kind of machine learning. So the concept of machine learning is to make the machines learn and solve problems. All right. So now I'll be talking about the aspects of machine learning. Okay. So one important topic under machine learning is called supervised learning. All right. So what we do in this case is we tell the machine that this is a strawberry, right? And teach the model by showing many images of a strawberry and telling the machine that this is a strawberry, right? And labeling the machine by this is a strawberry, right? So what happens is that after a long time, when you do it, the model gets trained, and then it believes that machine. It says that here is this is a strawberry. The machine is able to remember this is a strawberry. And this is similar like to our human brain. To a kid, to a small kid who's like 2 years or 3 years of age, right? When you show them only one strawberry, for one day, and then probably show an apple next day, maybe the kid may be confused whether this is a strawberry or an apple. But for a week, show the kid 100 types of strawberries. The next time you will show the kid a strawberry, the kid will say that this is a strawberry, because this is what the concept of supervised learning that we are trying to teach the machines with. Okay. Then the second concept is unsupervised learning, right? What is unsupervised learning? Assume you give these, a mango, a guava, and an apple to a kid, right? And many of them, right? Maybe give 10 apples, 10 mangoes, and 10 guava, and all mix them together, right? Mix them together and give it to a kid. A 2-year kid doesn't actually know whether this is a mango, whether this is a banana, or whether this is an apple, or whether this is a guava. And you say, tell the kid that put them, separate all these out. So since the kid doesn't know whether this is an apple or a mango or a guava, what will the kid do? Right? It will start the kid with his neural network in his mind with 2 years. Right? What will they do is it will start to separate them out on the basis of maybe color. Right? So on the basis of color, he says, okay, this is a red fruit, this is a yellow fruit, and this is a green fruit. Right? But he did not know this was an apple, this is a mango, or this is a. So this is called the concept of unsupervised learning, where machines, right, see patterns which humans can miss, right? And they would, and this is a very beautiful clustering. Unsupervised learning is used for clustering for a lot of times. But to keep the concept simple, right, we do not train the system, right, but the system is able to identify that, they are able to segregate the input data into multiple streams or multiple clusters based on some patterns that the computer see. Right? This is called the concept of unsupervised learning. All right. And the third concept is called the concept of reinforcement learning. Right. Let's take again a simple example of kid. Right, a 2-year-old kid, or maybe a 3-year-old kid who has just started, or 2-year-old kid who has just started to walk. Right, if a wall comes in front of the kid, maybe the kid would hit the wall, right, because he or she doesn't understand that the wall is a barrier. Right, and when they hit the wall, they get hurt, and when they get hurt, now they know that next time a wall comes in front of them, either they need to go left or they need to go right. Right, or can they jump over the wall. Right, so this is the concept of reinforcement learning, where the robot or the agent, moves from, goes to the environment, takes the action, and then the environment gives them a reward, whether it can be positive or negative. Right, and when the environment gives a positive reward or a negative reward, then they change their action accordingly. Okay, so, like, I gave an example of a kid. Similarly, robots are trained, right? Robots are trained to find the best path from point A to point B with many hurdles in between. Right, so eventually robot, you will try iterate once, and it will figure out, then it will go twice, thrice, and fifth, or maybe after 100 iterations, robot will be able to find which is the best route, which I can pass through barriers and reach my destination at the shortest time. Okay, all right, are there any issues? Okay, yeah, so that's the key. Yeah, so that is reinforcement learning. All right, till now we have covered this. Okay, so we have covered till now. What we have covered is the concept of the, just an idea of what is artificial intelligence, how do machines learn, and what's the concept of machine learning. The concept of machine learning, in terms of, there are three ways that machines learn: supervised, unsupervised, and reinforcement learning. Uh, so we have done all of this. Right, now let's figure out what's the difference between artificial, because we everyone is using interchangeably using what's machine learning, what is deep learning, what is artificial intelligence. Everyone is kind of interchangeably using it right now. Right, and what I see is that, this is what it is. Right, so artificial intelligence is the biggest subset, then there is a subset of machine learning, and then there is a subset of deep learning. Okay, so this is how it is. Although, so, when we call artificial intelligence, we say it is everything. When we call machine learning, it is a smaller subset, and then there's a smaller subset is called deep learning. Right, so as we humans learn from data, machines also learn from data, and that is the concept of machine learning. Right, uh, and there are, if I have to kind of categorize data into two types. Right, so one is structured data, and the other is unstructured data. Okay, what is a structured data? Structured data is basically any data that can be put in an Excel, can be represented in a tabular format or in an Excel format, and where you can kind of also derive insights from that data, right? Size of the house, number of bedroom, and the price it is seeing. Okay. Then there's a second concept of unstructured data, right? What is unstructured data? Unstructured data is your voice, images, messages, and videos. Yeah. So these are the types of data which we have. There are two types of data. Early in 2000, right, 2005, 2006, when Google developed its search, Amazon developed its recommendation, Bloomberg was providing high speed terminals, they were basically using the concept of machine learning, right? And the concept of machine learning works very well on structured data, right? They were performing very well on structured data, right? What is, in terms of the time spent on the website, what was the last search, in terms of a lot of these data which can be extracted from what a lot of these insights which can be extracted from structured data. But these machine learning algorithms were not performing greatly, and they were not performing greatly on unstructured data. So back in 2000, 2005, 2006, voice, videos, images, and messages, and all did not have a great, the machine could not derive great insights from it. All right. And that was the age where we were using majorly CPU, right, which did not have great processing power to work on the process unstructured data and make the machine learn through unstructured data. But in the last 1 decade, or maybe last 10, 15 years, we have seen the movement from CPU to GPU and GPU to TPU. GPU is graphical processing unit and TPU is tensor processing unit. And this has given us the capability of running, large neural nets, right? Uh, Previously, we did not have the capability to run large neural nets, right? And that was not democratically available, right? It was very few people. But what happened was, uh, with the great processing power, right? What happened was that if you could, so what happened in 2000, right? Was that with even great amount of data, right? The performance used to mature, right? With smaller neural nets, again, the performance used to mature here only, right? But with large neural nets and with large neural nets backed by high processing power, right? We could see that the performance was not plateauing. In fact, the performance kept on increasing. So the more amount of data in large neural nets powered by great GPUs and TPUs, great processing power, gave the concept of deep learning, right? Gave the concept of deep learning, and deep learning came into being accepted globally, uh, because not only gave great performance on structured data, but it gave good performance on unstructured data, right? And when it gave good performance on unstructured data, or everyone in the world rose up to this, because structured data, only 10 or 15% of all the data that we cover in this world is structured data. Maybe up to 90% of the data in this world is unstructured data, right? And that is the critical part of this whole thing, right? So this is the good performance that it delivered, and that then came the concept of deep learning, right? And what is deep learning? Deep learning is, through deep learning we are trying to map exactly how human brains work. Human brains is made up of billions of neurons, okay? And these billions of neurons are interconnected, and these interconnected neural network, right, of neurons, right, help us be humans and make decisions and learn and do everything. And when we take this interconnected network of neurons out of our brain and put it in a machine, it is called artificial neural network, right? this is the concept of artificial neural network, where these are neurons, right, where they are fed with input, and then complex problems require many hidden layer, and then we have an output coming out of these neurons, right? So artificial neural network is nothing but what we are trying to emulate is a neural network, which is in our brains, and our brain are made up of billions neurons, billions connections between those neurons, which help us become so complex and help us take complex decisions, right? And that is what is artificial neural network when it comes into a machine. Okay, so this is the concept of deep learning. And when deep learning we became, after 2000, 2014, 2016, as we kept on developing, our processing power became stronger, right? Today, you know uh, governments and organizations are kind of using to improve security, to manage cities better, using cameras and using multiple object detection. They're able to do so many other things. Yes, privacy may be one issue, but it has the benefits are also huge, right? Because it is helping in surveillance, it is helping in better city planning, it is helping in many other activities, right? So today we have those kind of applications which are going around the world. Then it has, now computers are talking to humans on a chatbot, right? And those capabilities have been made possible because of one thing, that is the concept of deep learning. Okay, um, and this is what how we differentiate artificial intelligence from machine learning from deep learning. All right. And if we were to segregate, so this is where we say, okay, this is the whole bigger set, artificial intelligence bigger set, and machine learning is a smaller subset, and deep learning is even a smaller subset. But if we divide them by timeline, right, then artificial intelligence is engineering of making intelligent machines and programs. Machine learning is ability to learn without being explicitly programmed, and learning based on deep neural networks. Okay, and it is very important, and all of them are function of the processing power that we humans have been able to build. So back in 1970s, we had huge computers, right? Heavy, bulky, and huge computers, right? When we came to the era of 2006, right? When we came to the era of 2006, of course, the computers were, now we had lighter laptops. Now we had mobile phones and everything, right? And by 2017, our processing power was even higher. Now we have almost the power of the whole laptop, right? Even more is available in your smartphone today, right? And this kind of technology innovation has made deep learning possible today, and we have the ability for the machines to kind of learn. I just wanted to show this and tell you that the beauty of artificial intelligence as a technology, amongst other new gen technologies, like that is your blockchain, AR, VR, and other technologies, is that artificial intelligence is at the core of all these technologies. One, second, it has an application across each industry, and within each industry, in each function. Okay, so that's the role that artificial intelligence is playing today. To also broadly classify artificial intelligence, you will hear terms like artificial general intelligence and artificial narrow intelligence, right? So this is another classification which people are talking about, and after the session you may want to also look at it. Okay, so um when we talk about artificial narrow intelligence, like your Alexa is an artificial narrow intelligence because it just does one thing. It doesn't behave like a human, right? It just, you tell Alexa play the song, Alexa plays the song, Alexa get me the news. So it is only doing one activity, converting from text, for converting from audio to text, then fetching the result, and then converting text to audio. Similarly, a face recognition app is just recognizing a face of a person and trying to find the attributes, right? That's all it is doing. So that is why it is called artificial narrow intelligence, and a customer query bot is only solving a query, right? So it's that is why called an artificial narrow intelligence. There's a concept called artificial general intelligence where a lot of research is being done to make machines as intelligent as human and give them the capability to interpret multiple input data points and take a decision from there, right? Not only doing one activity, but taking data from multiple points of multiple places and then intelligently doing an activity. And the closest application of artificial general intelligence we see today is that of autonomous cars, right? Because we are taking data from sensors, we are taking weather input data, we are also taking data from cameras, we are taking data from lidar, right, and many other, and then eventually making a decision whether to accelerate or decelerate, or whether to take a right or whether to take a left or whether to stop, right? So that's the closest we are to artificial general intelligence. Okay. uh, and the one of the most critical part that a lot of people use data science and machine learning interchangeably, and I think we have 15 minutes more, or 15-20 minutes more, and then we'll take some question answers. uh, so the difference between data science and machine learning, right? And people get a lot confused. Who's a data scientist, and who's a machine learning engineer? What's the difference between AI engineer and a machine and a data scientist, right? So this will help you solve this problem. Let's take a very simple problem, right? I've got second hand car. For a second hand car, I've got prices here, right? And the car length, the engine capacity, the fuel economy of the car, and the age of the car, right? And the price. So if there is a small car with 800 engine, fuel economy, car age, it is for $1,500, $2,100, 2,500, and all that stuff is there, right? uh, Now assume you are a second hand car dealer, right? You get a new car at your shop. What do? Would you find out that what is the price of this car, right? What will you do? Of course you will look at the size of the car. You'll also look, अच्छा भैया कितने की है इसमें 800, मतलब what's the capacity of the engine? Is it a 800 liter or it is 1200? What is the capacity of the engine? What is the fuel? कितना चलती है, कितने साल पुरानी है? And then you will have some numbers coming in your mind, right? ठीक है, अगर ये मारुति 800 है तो maybe I'll do it this much, and if this is if this is a big car like Verna or a Honda City, then maybe I should charge between 6 to 7 lakhs. You have those things going because you have these attributes in your mind, right? But eventually, what are you doing? You're coming out with a number, right? And this is the concept of machine learning, right? What it does is that it will take all this data, right, and develop a regression model, and this is the output data, right? This is the target data which you're going to target value which you're going to identify. So what a ML system would do, right? An ML engineer would be able to generate a model or a software to predict the price of the car, right? So you are going to develop a regression ML model to finally identify the price of the car. Yeah. On the other hand, so what happens, the customer comes, he shows, okay, this is my car, this. So what does the sales guy do? Sales guy would come, okay, punch in punch in the attributes of the car, and then you will have a price of that car coming out. And this is what Cars 24, OLX Auto, and many other second hand car online websites, right, do, right? So they calculate the price of the car there and then only using these kind of ML, machine learning models. Yeah. Now let's see what is data science, right? Now you have a presentation in front of your management, and you are a manager or you're a senior manager at one of these first choice. So first choice is one of the India's leading second hand car dealer, right? Run by Mahindra. So you go to first choice, and as a manager and a senior manager, and you have to give a presentation to your management to tell them, what how should they plan the next year, or how should they plan their marketing pitch, what should they do, what should they not do, right? So you as a manager, right, would like to see this data and see some and take some insights from this data and say, okay, let me do one thing. And this data tells me that small cars with even higher age but good fuel economy can fetch a better price than a small car with the same age but with a better engine, right? For big cars, the price is inconsequential of the fuel economy. What matters is the age of the car and then the engine. So, right. So let's look at big car. Right, on a big car, this is for $300,000. This is for $400,000. When what it actually says is that, okay, so the fuel economy doesn't make a lot of sense. Don't talk about fuel economy. What really matters is the age of the car and then the engine. So as per the inference, he figured out that the car age is more important, right, as compared to the fuel capacity. And this is what, these kind of inferences that you will take out from the data as a data scientist, and then you analyze multitudes of data and arrive at these numbers to give your management take these decision, right? So this is the distance, this is the very important difference between machine learning and data science. Although machine learning algorithms are used to derive data science, also derive data science, but data science as a field is about the science of extracting knowledge and insights from the data, whereas with machine learning, it is the field of study that gives the computer the ability to learn without being explicitly programmed. All right. And let me take a very simple example and explain you even more some of these applications. Right, so predicting stock prices, right? So on the basis of the last 50-year performance of a BSE Sensex, can you predict a stock price for the next day? I'm saying the next day, I'm not saying for next 50 years, but can you predict the price of Reliance tomorrow? Can you predict the price of Aditya Birla Group? Can you predict the price of Tata Group tomorrow? Right, and that is a machine learning problem, right? So you are going to take the last 50 years of data of Tata, maybe run through a regression model, and then identify and develop a model and say, okay, this is the price of Tatas. That may be a, so that is a machine learning problem that you're going to develop, right? Similarly, sentiment analysis, right? So probably that now you can identify sentiments out of statements, right? Whether this statement is negative, neutral, or positive. And this application is being applied by a lot of contact centers, and a lot of companies like Flipkart and all are using this to understand whether the review is negative, neutral, or positive, right? What is the review all about, right? So using sentiment analysis, they are able to identify whether this review is negative or whether this review is positive, neutral, or positive, right? Whatever it is, right? So they are able to do the sentiment analysis. And this is also this is a deep learning problem. So the difference between here, this is a machine learning because we are going to take the data which can be interpreted in a tabular format. This will, you will get a tabular format of all the stock exchange and everything in the last year, and then you're able to predict the stock prices. Out here you will get text, right? My experience with Flipkart was great. My experience with tripadvisor.com was not great, right? This is all when you put it in an Excel. You will have to apply deep learning, natural language processing algorithms to identify the sentiment analysis, right? So this is a deep learning problem. Um, Artificial intelligence is being also used in football, right? In which they are able to identify patterns, they are able to identify the speed of the player, they are able to identify how should a player move, what kind of teams should I buy, and what kind of players should be at what position. And that is a data science problem, right? Because you will get a lot of information that what is the speed of the player, what is the age of the player, how has it played last season, how is it played today, and a lot of other things. But what you are required to do is to what you are required to do is analyze that, right, and identify that which team should I select, which players should be at which positions, right? And at what pace should these players hit the ball, so that it hits for goes for a goal, right? So this would, you know, maybe this is somewhere between data science and machine learning, but I would categorize this as a data science problem. um, and don't take me for my words that, once I've decided, okay, this is machine learning or this is data science, because and these are all mutually exclusive. No, they're not mutually exclusive. They have some interlinking boundaries between them. There is intersection between them here and there. But right now, because this is the first step to artificial intelligence, what I wanted to was basically segregate them out completely for you, and then you could figure out what is the intersection between them. Or because otherwise, if I give you tell you that there is a pizza, and there is a hot dog, and there is a foot long pizza also there, then you may get confused. Okay, what's a pizza, right? But initially, if you know that all of them are different, right, then your clarity or your thought is very clear, and then you can say, okay, a foot long is like a pizza only, right? So that's what I want to build. But right now, I'm trying to build the fact is that what is machine learning, what is deep learning, what is artificial intelligence, how are they being applied, and they're not really about robotics. And I've told you some kind of covered some basics of artificial intelligence today, and tomorrow we will be covering a lot more deeper, that what are the 5 or 6 steps to solving a machine learning problem, how do we understand algorithms, and also help you kind of develop an application within 5 minutes using some tools there, right? So that will be interesting tomorrow. uh, and the most important part we have seen here, that what is artificial intelligence, right? So we have looked at what is artificial intelligence, but the very simple thing is you also need to understand that what is not AI, because else you will get only confused. Yeah. So what is not AI? So what is not AI is your smart TVs. They are not artificial intelligence. They are internet enabled televisions. Your smartwatch, every smartwatch is not run by artificial intelligence. And the beauty is that smart waters really doesn't have anything smart about it, right? It just goes water, it's a water, it's a water. I don't know whether it's smart or not, right? So that is what it is. Yeah. uh, and there are many of these problems, right? Other than robots going here and there, and then something of that sort. But there are many problems being solved by artificial intelligence, right? Like personalized recommendation, modernizing contact centers. They're improving surveillance, supply chain management, customer engagement, and improve health engagement, right? And in all these problems that are being solved, right, there are three people who are very, very critical. One is a domain expert, one is a product or a project manager, one is someone who understands AI and collects those requirements, right? And then there is a technology team solving the problem that you will tell them how to solve, right? And that is where you need to understand that how you as a manager, or as a as a designer, or as from someone, that how can you develop an AI mindset to solve these problems. Okay. And that is what some of these problems, like improving security, improving supply chain management, increasing customer engagement, has been covered as a project, right? Which the projects that you will be required to develop in our program starting tomorrow. In terms of admissions, which are starting tomorrow, and the program goes live on 31st, right? So these are some of the problems which will be, and we have covering more than 9 problems. There 9 problems are 9 projects that you need to develop and cover, and we'll so our approach is a little different. We go from, so you learn for to develop these projects. You do not learn to learn, but you learn to apply, is our concept that we have developed and designed this. And along that, you get mentor support, and we and you get placement support if required, right? So basically, we put you in a shell where you learn and apply through this program, right? and very important, even if you don't apply in the program, however it is, just don't be scared and just be prepared, because it is artificial intelligence is coming, and we just need to be prepared, and we need to identify where we want to be. Do we want to be a part of that 75%, or do we want to be a part of that 25%, right? The world is talking about only those 25%, but I'm telling you that corporates are looking for those 75%. Okay, so that's key to this whole game. And today I will leave you with something very interesting, right? So I thought, like, we are speaking a lot of things today, and done a lot of study. Let me also leave you with something pretty interesting, uh, to so that maybe you come back tomorrow having built something. So today what I'm going to do is make you develop introduce you to I'll introduce you to a very simple uh, deep learning development platform, and I would want you guys to prepare these models and come back tomorrow, right? And if you guys have and you can showcase me, it will be great, right? So there is this platform built by Google called Teachable Machines with Google, right? Please have a look, and it will be a great start, and this will be a best start for you, the first step. All right, and I want you to build a project tomorrow, all right, and come back to me, and that's what we do, because we want to learn. We want make you learn through projects, right? So I'll build a project in front of you. So this is a deep learning based project, and we'll talk about it tomorrow, but I'll make it, and you make some of them today, right? So let's do an image recognition one. All right. Right now, I'm developing image recognition, facial recognition, deep learning model to identify whether I look like Tom Cruise. Sorry, do I look like Tom Cruise, or does Pallav Modi look like um, Tom Cruise and Leonardo DiCaprio? So people do not know Leonardo DiCaprio and Tom Cruise are, leading Hollywood stars, and I'm just building a two-class classification model. What do is, like, I've taken Tom Cruise, and now I'll train the model. I'll just take some files from here. Online workshop. Okay, Tom Cruise, right? So let me take some images of Tom Cruise, right? So we need to make the machine learn, right? Who is Tom Cruise? So I've taken these images, 5 sample images, and asked them to, this thing. Now, okay, I have taken, so and these images I've downloaded from the internet, right? So for everyone's perspective, and I put it in here. So I've taken 5 images here, and let's get them to train. Right now, you have not coded one single bit, but you're training a deep learning two class classification model, and you have now built an application which identifies whether you look like Tom Cruise, or whether you look like Leonardo DiCaprio, right? So I'll do is I'll just put the input webcam. I'll take the file. Uh, go on. All right, I'll take the file. So first I'll just check whether the model is working fine or not. So I'll just open this, and it says this is Tom Cruise. All right. So it's an output which says it's Tom Cruise. Now let me take my image and see whom do I look like and have a good day about it. All right. So where is my image? Okay, Pallav. Great. I look like Tom Cruise. Awesome. Right. Now let's see you build between a Hollywood celebrity or a Bollywood celebrity, and let's see that whom do you look like. All right. And using teachable machines, and let's come back tomorrow. And if you're able to submit me the link, and we can showcase your project tomorrow in the class. and explore teachable machines. And there are many more tools like these which can help you build projects simply, right? But it doesn't end here, it starts from here, right? How do we use tools? And this is only one kind of a tool. There are many other tools which we explain as a part of the program, which can help you solve complicated problems by developing an AI mindset. All right. Tomorrow, we will be understanding. So tomorrow, just before we just I take a step back and then I'll answer more questions. What we do tomorrow is we cover two three things tomorrow, right? One is stepwise approach to solving a machine learning problem. We'll also solve an e-commerce problem using natural language processing, and also some hidden surprises there, that some tools to get you started, and also maybe explain you that what more goes into developing this program and how have we developed this program. But more, it will be more application oriented tomorrow. We'll talk about algorithms. We'll talk about a stepwise approach: step one, step two, step three, step five, step six to solve a machine learning problem. We will also look at algorithms. We'll also look at some of an interesting e-commerce application, and that is a real life Flipkart application, right? How Flipkart used AI. We'll talk about that tomorrow and cover more applications and have more fun tomorrow. Right, so see you tomorrow. And of course we are going to do this, right? So this is your home. This is a project that you need to, so let's define a project. Okay, so create an application which identifies the celebrity you look like, right? I've just taken 5 samples. You can add many more samples, you can add many more classes. uh, you can develop something on women, you can develop something on men, and do a lot of other things, right? So let's do this tomorrow. It will be really fun to see that, how can we have fun with artificial intelligence. Yeah. All right, so now, after a long marathon run, uh, I have kind of uh, come out of the presentation zone, and uh, we have a lot many questions.
So while Pal
Um,
goes through the questions in the chat, I'll just jump in. Hi everyone, I am Savinder. I'm the founder at Pragmatic. Thank you so much, Palak, for the incredible session. Honestly, AI is such a complex thing because the only thing I see when it comes to AI is research papers, and research papers kind of always make things pretty scary, right?
right.
So that was that was the core endeavor while making this AI program as well as this masterclass and overall whatever we're going to do in AI. That let's simplify this. It's not. Am I not clear? Am I audible?
Yes, you are to me.
By the way, everybody is unmuted now, so you can unmute yourself and we can have a interaction. Okay. My voice is feeble.
Hello, we can hear you, Dalwinder.
Okay. Okay. So I'll try to increase my decibels. So I was saying the whole purpose. I mean, when we were me and Pallav were ideating on how to approach this AI school of AI that we are launching. I think that the it came down to very simple core value that AI in general has been made very complex. It is a complex subject, no doubt about that. It's a complex subject. There's a lot of maths, there's a lot of statistics. I, for one, didn't like maths ever. I was a physics guy. Right? So AI was always, all sort of maths, all sort of probability, all sort of statistics. Too much to understand, too much to learn. At the same time, I didn't want to become an engineer, so to say. Right? I just wanted to learn enough to be dangerous. Put very simply. And so that is where the masterclass came in. That is where the certificate program that we are about to launch comes in. That we believe that not all of us need to be engineer. We don't need to know how to code and create algos and stuff. We just need to know when will the algo perform well, when can I trust the algo, when can I question the algo, and what questions to ask the algo, to be very honest. So that was the intent. Thanks, Palla, for taking such a fantastic session. Everyone, I think I was trying to answer as much as possible in the chat. There were a bunch of questions asked. I think the last couple of questions have been left unanswered. I left it. So one was by Ankur, which was sentiment analysis would work on labeled data sets, or is it a RL problem? RL is what?
It's a reinforcement learning problem.
Yes.
So it a lot depends upon I'll tell you that sentiment analysis first can start with supervised learning, right? And today we have a lot of these already established models which have been developed, right, by Google, AW, Amazon, which can be readily used to solve 90% of the problem. Okay, now the last 10% can be very domain specific, right? I'll tell you an example, very simple, right? You go to an event, right, and there is a concert, music rock concert going on, right? And suddenly people start tweeting that this is an amazing, the stage is set on fire, right? And this guy is killing it, right? Now assume this tweet is being read by a police, a police engine, right? On the other hand, this is being read by Book My Show, right? Now the context is pretty different here, right? Although it is the same thing which they are saying, right? But to a police, the stage is on fire, right? They have to go, right? So this is where you could have, like, make the model more complicated and then used RL, wherein you, for a police, it would have said, okay, these kind of tweets don't make sense, let's put them in a negative basket, not in a positive basket when it comes to entertainment. But for Book My Show, it was a positive tweet. So it becomes context oriented, that you have to, first model is the base model, and then from the base model maybe you develop an RL model, or you develop unsupervised learning model. Is depends upon the context that you have to build on it, right? Does that answer your question?
It does, Pallav. If I can just ask one specific thing on that.
Right.
So, for example, let's say you got a list of tweets, right?
Mm-hmm.
Then we will have to train the model on something very specific, that this tweet means that you have to do this or you have to do that, right?
Right.
How do we put penalty or an benefit on it? Because it's more of a classification problem than something else, right?
Right. So in that case, Ankur, I'll maybe take this offline. This is a
Sure.
little very, I would say it's a, tweet. There are multiple stages
Okay.
to analyzing a tweet. So a tweet can be analyzed very differently by an e-commerce company,
Uh-huh.
right? And a tweet can be analyzed very different by a government organization.
Okay.
You get? So you have to define that why are you looking at that tweet? Right?
Okay.
And once you define that, then I can tell you, okay, first is to find the authenticity. So first model is to find whether the tweet is authentic or not. Then you build another model on it, whether this tweet makes sense or not. Then you build another model on it, whether this is spam or not. So first you do all that, then you keep building models on it, and then see that how it works. And maybe that the model you are talking about is the last model,
Got it. Got it.
right? Where you are looking at the accuracy of your model, right?
Hmm.
And then you define, okay, my accuracy is going low with whatever I tried, let me try something else now.
Right. Got it.
So it's a little more very extremely complicated than I could answer you right now, but that's
No,
what.
but I get that, Pallav. Thanks for the answer. Thank you.
Yeah, yeah.
There's a question, Palav, from Abhishek. If I
Mm-hmm.
want to analyze order cancellation reasons in an e-commerce website, which model should I use?
Okay, all right. Again, you know it very pretty well, right? Order cancellations, there are many, many, many reasons. So first you have to identify the reason before identifying the model, right? First you have to identify the reason, and first, as that's a product management problem, right? That why is the order cancellation happening? There can be many reasons. First is that maybe you're very simple, and maybe this is not related to even AI, right? That your payment page is not opening, right? There's some problem with the payment page, that your order is getting cancelled. Second, there can be another reason, that people are putting it in the cart but they are not paying for it, right? Maybe there's some UI UX issue, for low convergence, right? So you will have to look at multiple reasons and then first identify that one reason, right? That there is this reason that the people are not coming to, there's some problem with order cancellation.
Right.
They want to come in.
Yeah. So I think like almost. So I typically say that these decision making problems ultimately comes down to five. When you're building a model or any product, there are five dimensions to it, right? There is you discover the reason or the idea, the why. You discover the why. You decide which why is important, right? So that is where the prioritization everything comes in. Then you design as to okay, I've understood this why. Now let me design some experiments or some hypothesis, something.
Right,
Give me validation that my why was correct.
right, right,
Once you have done that, then you come to the development part, then you come to the deployment part. So in
right,
your case, if you want to analyze order cancellation reasons, I believe if I was you, I'll first of all look at what is the number of orders that I'm actually getting. If the number of orders is small enough, I'm saying like 100 orders a day or 50 orders a day, then perhaps just doing a basic optical analysis itself will be more than sufficient to understand what exactly is the reason.
right.
Assuming,
And sorry,
assuming you're collecting the feedback from the users as to why are they canceling it, right?
right.
That's one. One, if the orders are higher than 100, maybe 200 per day, that's when perhaps you will start applying some of these models. But you will not apply models like let's apply this one, let's see what we get.
No,
So,
but Talvinder, I have one answer to it. It's just like now I just registered in my mind. So one way in e-commerce, artificial intelligence is being applied to identify the reason. Not identify the reason, but identify that what kind of people, right, are canceling more, and what are the reasons for them canceling. That is the second where you said discovery, right? So
right,
if you can see, if you can identify, okay, these are the set of people, right? These are the 100,000 set of people who are canceling. Now you apply unstructured learning on it, right? Unstructured learning algorithms or unstructured learnings, and then identify the pattern in them which a human eye is not able to see. So maybe you can identify that moms, that women in the age of 30-35, moms having kids as soccer kids or soccer moms are canceling the most. So these are things which you kind of identify and cluster, and then you build for them, maybe something of that sort.
understood, understood.
So these are, you can of course apply unstructured stuff on a lot of these data to identify patterns which you cannot figure out normally.
Right, right,
Yeah.
right. That makes sense. Okay. There was this one very interesting question from Niti, which was business teams struggle to identify problem areas or focus on very. So either they struggle to identify problem areas or focus on very incremental stuff that can be
Hmm.
compared to automation or rule-driven approaches. But those automation and rule-driven approaches are a little long-term focus, right? They take some time in.
Right.
So how to build that mindset? I think
Um,
are you a product manager by any chance? It sounds like a product manager's
right.
problem.
So how to develop Niti a mindset from a product perspective for a product team, or from a organization point of view, right? Is to see, for an organization, making a big shift is always very difficult, right? Because they have structured revenues and everything, and stability is something which is very important to everyone. So usually what I suggest to a lot of these corporates when I do these workshops is to take small steps, right? That is one. Second, do a project, take do small projects, right? And do not look at hiring data scientists or something. Do small projects, right? And those projects should not have a very, very big impact on your ecosystem, right? Because what happens is, first you need to develop some confidence, right, in that through those small projects, and then that will give the enterprise the confidence to scale that project to even bigger, right? But if, when a lot of people would come in and say, okay, AI will transform your customer experience, and you go and tell, and then the people like, dude, man, I'm here for last 50 years, ठीक है, मुझे मत बताओ, कि तुम ट्रांसफॉर्म कर दोगे एक दिन में और एआई रोबोट करेगा. सो दीज आर सम एप्रीहेंशंस व्हेन यू से आई विल ट्रांसफॉर्म, right? But when you say, okay, in customer experience or in customer contact centers, what I'm going to do is help my agents solve the customer query faster. All right, I'll just take that bit and only work on maybe a natural language processing or a voice AI system where I'm able to only identify whether the person who's speaking is angry or not. That's all. And you tell when, and analyze the system when the person is angry or not, and tell that this is what you need to do. That the agent tell the agent and maybe give a pop-up that the customer is getting angry, now tone down. That's all. So this is a very small project, but this is how you can build on your projects and build those small and become an AI champion in your organization, for that matter. But don't tell to do a very very big transformational thing, and that will usually face a lot of hindrances.
Yeah, I mean, so I typically like to just to add to what Pallav is just mentioning. I typically like to give you a certain timeline, right? So all so when we think in continuum, we feel that there is infinite time that we have, but in reality, every company works in quarter to quarter, tak, right? QSQT, right? That's what every company operates in. So, as a business leader, as a manager, whether it's product manager or any kind of business leader, you are also bound, whatever experiment that you plan to run, whatever thing that you want to run, you are bound by the quarter's length. A quarter's length is about 12 weeks, right? Um, Sorry, 16 weeks. So in a 16-week period, you would want to ensure that whatever you're doing, it is resulting in some positive action, right? So if you're just starting up, ensure that it's a 1 week, 2 week experiment that you can immediately show results in, and you can implement in the same quarter, right? And once you have proven that in the small 2 week thing, then perhaps you will get a leverage that, okay, now you can run a larger experiment of a 1 month, 1.5 months. That's how you need to think of, right? Like in a product manager's context, for example, when we set up our roadmaps, we don't look at, we are setting up in the sense that there are 52 weeks. Out of the 52 weeks, 48 weeks are actually workable. 4 weeks easily go in holidays and some stuff. Out of the 48 weeks, we can only do about 8 weeks would simply go in bug fixing and bug fixing as well as maintenance and those kind of work. Ultimately, we got 40 weeks to develop new features or to develop any kind of innovation, which basically comes down to every sprint. Every sprint takes about 2 weeks at the bare minimum. A decent sprint is going to take 2 weeks at the bare minimum. So that leaves us 20 sprints in the entire year. In the entire year, 20 sprints. So 20 sprints, if you have a decent technology team, you can expect X number of features, right? So you can expect one average feature size is about, I don't know, 4 hours, 8 hours maybe, right? So if you start quantifying that way, you will realize that you only have these many bets to make in the entire year, right? So when you're going for you're trying to transform your business or you're trying to input your business to be a little more forward thinking. If you give them such very quantitative approach, I've seen that people transform. They look at it very differently. That okay, out of these many bets, I'm betting on this little time. If it doesn't work, it's okay. It's not. We are not losing the entire ocean for few holes. Yeah.
So where I was coming from was that see, big corporates are one of which I work for. They went through this whole Six Sigma process improvement kind of methodology, right? Where they had a very structured way of identifying the problems and then figure out the solutions, right? So they are very used to some kind of structured approach. But when it comes to AI, ML, and deep learning is still like far away, right? Like how we should figure out where we can use it, because I think if we, like Pallav, you said in the beginning, right, that business plays a very big part, right,
Right.
to get the project or any initiative started.
Right.
But if they are not able to come up with any ideas, you can hire as many data scientists as you
Oh,
want.
of course, that's there. Right.
Nothing will happen. So how do you make it more structured to help them think in a similar way? And I'm talking about big startups, not no, sorry. I'm talking about big corporates, not
Mm-hmm.
that have people who have newly joined or familiar with new tech. It's extremely difficult because when you ask them, they will come up with some small stuff that you can do, which
Mm-hmm.
just put some rules in a rule engine and get going.
Right.
You don't
Right.
need AI for that.
So Niti, this is a very similar problem around like pre-COVID, I would say, right? In an organization, in a big organization, I had the same thing going on where there was a very they hired a lot of engineers and they started working on these. So it was a service-based company, and they had told their clients that we can develop AI and ML models, right? And we can work on AI and ML projects for that matter. And they taken up a project. They got some engineers who written on LinkedIn. They had done even not to say, but they had done some great online certification programs, right? I got a chance to meet them in my first step to AI conferences and the corporate, and this was a very similar problem. Exactly, you said, Unity, that they had built some simple recommendation engine. They built some simple visual recommendation stuff, right? And they could not think of from a very planned or from a project sense that how can we deliver this project as a project, right? So what my understanding has been, Niti, in that sense is that it is a cultural issue, and this cultural issue comes from this fear that somewhere the fear is that a data scientist will do everything. I don't need to do anything. And this cultural fear, which kind of doesn't make people kind of get into this mindset of understanding AI the way I kind of try to put it, that it is simple, it is around you, and also you can do it. So once people get the confidence that they can also do it, is when you will see the leadership also falling in place. That's my understanding.
Yeah, I mean, I think it's the one. So culture, I think, percolates from top down, and I think two things happen. Either people get so they take an action out of FOMO. If my competitor is doing it, so I need to do it. That's one way to drive action. And the second way to drive action is where the internal team, internal stakeholders, small teams are showing good results. And wo kaise aaya? How did that change happen? Because we experimented, we tried something new, and that resulted in better shift. Having said that, yes, I've seen companies, very large companies, being extremely slow and lethargic in adopting even the best practices that have been proven in their company. I've seen that happening. In those cases, it's very hard, honestly, to change the culture of everyone in the entire stack. The best you can do is that within your sphere of influence, if you can make changes and hope for the best, and if that is also not making sense, then change the company. Honestly, there are certain.
Okay, that helps. I think the point on doing smaller projects first is probably more
Yeah.
useful
Even
and
than going
even
for the big.
and
even
driving the project to not being a project but driving an objective to that project. So that is like, not make what is the problem is that we can do this, but what is the, so the OKR, right now, what is the objectives that we are driving through this? Are we going to, so if you have your business objective very clearly defined, that after doing this my customer satisfaction score will improve, or my team engagement will improve, or it can be a very small quantifiable value, and you derive towards it. But don't say, okay, I'll make a model. So simple. Someone said, I'll make a image recognition model for recognizing watches. But how does it help me? If it doesn't help me, then it is just a project, which has no value. So that's what I think.
ultimately, I've seen that in in startups as well as large corporate. I think large corporate is even more. Ultimately, what matters is what matters is uh, am I getting more profit? Am I getting more users? Am I getting more retention? Am I getting lesser order cancellation? Now, what is the way to achieve it really doesn't matter too much unless and until you're going to charge a bomb for it or the cost of bomb here. I'm going to reduce your order cancellation by 20%, but I need a 5 people team. Like, mat karo bhai, because that cost itself is going to, cost of hiring the 5 people is going to overtake the benefit of reducing order cancellations, right? So, if you can just keep that focus in mind and then go back to the means of achieving it, whether it's AI, it's ML, or whether it's some other hack that you have codified, really doesn't matter.
And that 75-25% ratio, which is very prevalent, that the project success of any AI thing is only for onto those 25%. This is also a challenge. That's
Yeah, sure. Thank you. Thanks for
thanks, Nikhil.
response.
Right.
Any other questions from anyone?
Yes, we have one question from Vivek. How vertical knowledge is important for AI?
Oh,
How
it's
vertical knowledge, domain knowledge.
domain knowledge, right? It's extremely important. It's I would say when like if you are in a vertical and then you have that AI knowledge, then you can do wonders of developing some innovations in that vertical, right? But if you only have AI knowledge, right, where would you apply? You have to apply in a vertical, right? So vertical knowledge is pretty important in applying or championing the cause of AI in your industry, right? Without that, you will not understand your data. Well, you will not understand anything. So I would say it's pretty critical having a good understanding of a vertical, and that will help you transform many processes, not one process. Then.
Right. I think just to add to what Pallav said, I think like some time back we were talking about the tweet analysis of tweet, right? If you do not know about your domain, you will not even be able to understand whether this tweet is useful for you or not. You have to look at the tweet in the right way. Similarly, when you're making those decisions or you're kind of creating a recommendation engine, for example, let's say for I'm not into fashion. I did fashion for some time, but I'm not into fashion, for example. So if somebody actually asked me to make a recommendation engine for a fashion app, I'll struggle to figure out what aspects do people really care about, in fashion.
Right.
Fitment or the length and this and that, and I'll be baffled that okay, there are so many attributes, right? So having that kind of in-depth understanding or nuance of car selection, for example, like for the beyond the color, beyond the regular stuff that everybody looks at, what else to look at? I would not know if I'm not in that industry very well. So it's critical, especially when you're making moves. Any other question for you, Piyush? We may have covered on YouTube. Maybe somebody might have asked, or on
No,
the
that's all.
awesome. I think so. Today, I think we are good on time. Huh? Two
Yeah.
hours. We are exactly bang on. Good.
Right.
So at this point, thank you so everybody for attending. 25 people are remaining. You are the two champions, two folks. Um, There were about 50 till the Q&A started. So we have seen that happening quite
Right.
tomorrow, I think we'll be covering a lot more in depth in terms of whatever we covered yesterday. I should not be like
Right. And it will be great if we can have some interesting projects coming through teachable machines.
correct. So tomorrow we will be covering those actual projects. Some projects we will be doing, some projects we will be doing, and the session will end with actually building a project by the end of it, right, Palav?
Yeah, maybe we'll try. Well, not a project, but understanding how to develop a project, and we'll also do some kind of small stuff here and there.
See you everybody tomorrow, and have a good Saturday, safe Saturday. Bye.